page to Roberto, and then yeah, sorry, Roberto. That's right.
Okay. So good morning, everyone. I want to thank you for participating, and I also want to thank Simone and then Professor Manuel Gil Perez from Spain. Simone works within the team of the SoftFIRE, while Professor Perez represents an experimenter. And so he will illustrate he will explain to you what they have been doing. I think it's quite important to show how people have used the platform. So I will give you an introduction. You can stop me anytime you have a question. Then Simone will provide to you further technical details on how to use the platform, and then we will have a demo about the one of the experiments. So I'm Roberto Minerva. I work for AT Digital in the Italian node in Trento. I am the technical leader of the SoftFIRE project, and that is a burden, but it is also a big honor for myself. The project is closing its activities by end of April, and we wanted to end this with something that we call the Innovation Hackathon, to which you will participate. And the idea was to show how the project during the time has reached a kind of consolidation of the platform, and then we will give this opportunity to use the platform hackathon, supported also by Ericsson in Rome, in order to show that we can move, we as a community, a technological community, to an industrial development of many of the things that have been considered, used, and possibly developed by the project. Just to talk about SoftFIRE in a very small way, there are 8 companies: AT Digital, ADS, Deutsche Telekom, Fraunhofer Focus, Ericsson, Reply Security Valley, Technical University of Berlin, and University of Surrey. So as you can see, the consortium is covering both the academic research as well as, let's say, industrial research, as well as some strongly involved partner into the industry. The total duration is 27 months. We had a budget of 4 million €, and half of that budget was devoted to open calls and external participation. So a lot of work related to the project has been devoted to support experimenters, to support external people that were using the platform. What we have been doing is 3 waves of experimentation. The first one was essentially carried out in the first year, and we carry out an interoperability test that was used in order to show that the platform, the federated platform, was up and running. Then we issued the first open call, and we received more than 20 applicants, and we selected 6 winners. The first wave was quite selective. The reason for was that the platform needed to be stable enough, and some of the projects, the proposals were not aligned with what actually SoftFIRE platform was supporting and providing. With the wave 2 starting, let's say, from January 2017, we changed the architectural approach totally. We gave up with some FIRE tool, JFED and FITEagle, and we introduced our own middleware, and we were running the second hackathon and running the second open call in which we were experimenting with 13 experiments. Then, let's say in September, we started to have the third open call, and we just finished, it was in mid of March in Paris, with a challenge with more than 15 applicants. And we had a participation to the IATF hackathon, just to promote the platform within the standardization. And we also are going to have this innovation hackathon in Rome. So this is the landscape that we built over the time, over these 2 and a little bit more years. The technical goals of the SoftFIRE are very simple, if you want. One is the creation of a federated platform in order to create a community and to jointly study some issues toward the 5G. We were also aiming to a better integration between NFV and SDN. And another point that could be extremely important for, let's say, the industrial users, the integration of security within the platform development. That was also one important point that from the industrial level is extremely important. Opening up APIs, opening up platform without security mechanisms is not a winning move, and we wanted to study a little bit what kind of security issues there could be. And then in order to assess the technologies, we were also providing, defining and providing a large set of KPIs that were intended to cover not just the, let's say, the platform behavior, but also other different features that the platform was providing. One for sure was the security. So having logs means that you can measure also some security threats. And we were also aiming to measuring some programmability capability of the platform. How long it will take to deploy, how long it takes to ask for functionalities within the platform. So something related to programmability as well. The SoftFIRE approach is quite interesting, I would say. There is the 2 different approaches lives together, so to speak, a bottom-up and a top-down. Bottom-up because we started from very different testbeds, and these testbeds were very different in scope and in technologies. Think about the Ericsson, for instance, testbed, and think about the University of Surrey testbed. One is for sure devoted towards at least industrial developments, while the University of Surrey is for supporting research and for opening up new issues and to solve them from the scientific and academic perspective on 5G. So you see, having these different testbeds and to put them together, it was a challenge in itself. Then we have also a top-down approach in which we were starting from requirements from the experimentation, from the standardization effort, and the team was working in order to create and making available an open, programmable, and secure middleware infrastructure. The other point that SoftFIRE is very proud of is openness. So the software project has tried to create an open platform, even if the companies that are providing the federated testbed do have different approaches and policies in opening up. In the first year, we had a strong involvement of an operator, and I can assure you that the policies of the operators were very different from the policies, for instance, from a university. And so to bring all together and to provide a real federated and working environment was very, very difficult. But finally, we managed. The software that we are going to describe and to use is, what we want to do is to provide integration of network function virtualization and software-defined networking. We want to provide a software environment for the experimentations in such a way that people can program, can instantiate, can program, can modify, can debug their software that should be distributed over different testbed. And we would like to use these capabilities in order to anticipate a little bit the needs of the, let's say, software network architecture for the future 5G. Here in the picture you see there are applications that will use the Experiment Manager in order to instantiate over a virtualized infrastructure manager that is supporting for sure physical resources, virtualization, and also other functionalities like SDN function and related APIs. So this is the approach, the general approach we had. Sorry, the federation has been, as I was telling you at the very beginning, it was a little hard to achieve, but then I would say we learned how to achieve, and so. Here you see there are a number of testbeds that have been integrated. Ericsson, ADS, University of Surrey, Focus. TUB is also involved in this development. And we were also able to integrate other testbeds, for instance, Telecom Italia Mobile, as well as Deutsche Telekom testbed, as well the AT Digital in California. Just to mention the partner, but also during the second wave and the third wave and the challenge, we were able to integrate into this infrastructure also testbed from external partners. So at the end, after a little bit of tricking and development, we were able to quickly be able to integrate other testbed into our platform. Interconnectivity between the testbeds, well, for sure, we do not have special connectivity links between the different testbeds, so we use the public internet. We are also using layers of tunnels. We use OpenVPN, and at the very beginning, it was a little it's tricky to keep track of all the addresses, who is using what, and things like this. So as you can see from the picture, there is a complexity here to manage. So then I think Simone will ask you, in order to access to the hackathon, to configure your OpenVPN. That is essential for providing a minimal level of security, and we have been working on this level of security during all the project. Then we have three major objectives that we have declared, that we have stated towards the European community. One is to show interoperability between the different federated testbeds. It was very hard. It is very hard to maintain a federated testbed that comprises different testbeds with different needs and different policies. Then, from the software point of view, interoperability has issues everywhere. At the very beginning, we were struggling between OpenVPN and OpenStack relationships. Then we learned how to solve those, and so we moved to other issues. And for the time being, I think we have a good experience in how to maintain this. Then interoperability for SDN was a little bit tricky because we are supporting different SDN flavors, and we have not been able, for several reasons, to provide a global orchestrator of all the SDN functionalities. Essentially, we were trying to use OpenDaylight VPN But when we started to deploy, the software was not so consolidated, and so we didn't want to provide additional issues for the experimenter. So we always have to trade off between nice and experimental functionalities and something that was stable and usable by the experimenters. For sure, having so many different test beds has an impact on our orchestration, but we think that Baton did its job and our middleware pretty well, and there is a lot of effort to put into the management of the interoperability. And then we have seen that, at least in what we have been doing, NFV is a little bit more consolidated and standardized, while SDN is a little bit more industry focused with different fora and different initiatives. So we had to choose a little bit of the technology that was deployed into our federated test bed. Another point that we wanted to make was to guarantee programmability. So let's say programmability has two dimensions here. One is related to the functions that you want to use. So what you want to program, for instance, SDN or a terminal into this network. You want to monitoring some certain resources. So you have to access to certain APIs, and then you have to decide how to deploy, where you want to do, when do you want to execute certain functions. Actually, this was one of the major initial issues, because sometimes the experimenters, I suppose this is not your case, but at the very beginning, the experimenter were not too much familiar with the idea of having a distributed architecture. So they were a little bit in trouble in understanding where to put the things into our infrastructure. I think we have plenty of interfaces and APIs, and this is a good thing. Hello? I think having a lot of APIs is a good thing, but it will introduce some complexity. And many times the software bugs are a combination of small issues that are coming, let's say, from the infrastructure, from OpenStack up to the application that the experimenter is deploying. So doing debugging in this federated testbed is something that has required to us a lot of effort, a lot of cooperation with the experimenter. But in any case, we think we have a lot of functional capabilities, and there is a lot of space, room for extensibility of what we provide. The third feature is security. So we have interworking, interoperability, programmability, and security. It was difficult to provide an homogeneous set of functionality into the different federated testbeds, because of what I've been telling you before. There are different policies, there are different rules. Certain companies are very strict in who can access, what kind of data can be extracted. So we had to work a lot with single IT departments, for instance. Then we came out with a different approach. The idea was to provide a set of security functions to programmers and users of the platform, so that they could start building some secure application using some basic functionalities. And we also organized the security management in such a way that additional security functions can be introduced over time. Another point that we wanted to make, that is not that originally it was not related to the experimenters, was to make a lot of measures about the platform. So we wanted to have resource-related KPIs, how the computing nodes are working, platform-related KPIs, how OpenBaton, how OpenStack is working. We wanted to have some security KPI, how the programmers are doing, what kind of processes for developing the software on top of SoftFIRE are taking places, and to measure them. And then when an application is running, we wanted to have application-specific KPIs. So we produce a very long document with plenty of KPIs. And initially, the idea was to have the project working on the KPIs. After a while, starting from OpenCall 2, it was clear that all the experimenters were needing to have their own KPIs for measuring what the project was reaching. So we moved a little bit to follow what the experimenter were doing, and all the experimenters were requested to provide a verification of what they have been doing in terms of measurable KPIs. And I think that was a great move, because it was giving to the experimenter the idea of what practically they were doing, and was giving to us a verification of the important KPIs that experimenters want to use. Okay, so probably you know this network function virtualization ecosystem. This is the ETSI definition. As you can see, there are a number of technologies supporting. We have been choosing to use OpenBaton as the orchestration, and we strongly rely on OpenStack as for the management of network function virtualization. So OpenStack, we believe, is the de facto standard for the implementation of the management of the infrastructure. At the beginning, it was a little bit tricky to compare the OpenStack. We were using different versions of OpenStacks, and many companies were a little bit reluctant to move to the next version. So we had also some interoperability issues with not fully compatible OpenStack versions. But I think now we got a little bit more knowledge about how to do it, and also OpenStack has moved to a more consolidation, and also is supporting backward compatibility. OpenBaton is our orchestrator, so its functionalities are related to support how the different functionality can be deployed and virtualized over a distributed platform. Then we were using OpenDaylight and openSDNcore. OpenDaylight, I think, is well known as SDN controller. openSDNcore has been developed by Focus in order to control SDN functionalities on the Focus testbed. So the idea was also to move to service function chaining from OpenStack, and for instance, the ADS testbed was providing this kind of functionality. So as you can see, we were lacking a global SDN orchestration, but that was how to say, compensated by the fact that people could decide to use different interfaces or different implementation of OpenDaylight. By the way, some of the experimenters were able also to use the two different interfaces in order to create their own orchestrator. So the software high-level architecture that we have been organized is comprising, I would say, three major levels. So we have the OpenStack testbed. This represents a collection of multiple interconnected testbeds that are, let's say, harmonized by the OpenStack environment. On top of that, we have chosen an NFV Manager, that is Open Baton, and so its job, its goal is to orchestrate the functionalities on top of this testbed. And then, in order to support better the experimenters, we have introduced our Experimenter Manager that is requesting to the experimenter to define and to describe by means of Tosca the resources that the experiment wants to have, and then these resources will be verified and implemented by the experiment manager. So you have plenty of possibility to describe and allocate resources. The middleware, the SoftFIRE middleware, has been completely built from scratch and implemented in Python during the first months of 2017. It went through a long consolidation, and I think we reached a level of confidence with it just during the challenge. The challenge is then I will talk a little bit about the challenge, I suppose. It's based on microservices, exposes Tosca API, delegates specific operation to some sub-manager, and we will see what kind of manager. So in a sense, we were trying to provide an architecture that is more aligned to the needs of virtualization and SDN, and to support the Tosca description of resources. And we think that was a tricky point at a certain point in time, because we state this movement from, let's say, the typical Tosca, typical FIRE tools to the to some tools more aligned to the virtualization ecosystem, and the reviewers were saying you can do that, but you have to collect indication from your community. I think a lot of experimenters have found this move quite interesting to them, and I wouldn't say, and I would say that nobody was complaining. I think it was a smart move from our part, and it was also essential to the experimenters. This is the high-level middleware architecture. You can see the experiment manager is providing some dashboard for defining things, or CLI. The major manager are here in the first level. You can see there is an NFV Manager that is supporting the virtualization capability. There is an SDN Manager that is able to instantiate different SDN controllers. There is a monitoring manager that is able to be instantiated and to be programmed according to the needs of the person or the experiment, in order to collect by Zabbix the important events and monitoring needs of the experimenter. We have implemented this security manager that is with some functionalities related to security. And there is a physical device manager that is used in order to allow people to access to the physical resources of the University of Surrey network. The University of Surrey is providing also LTE access network, LTE-based access network, and it has made available a means to configure and to work with physical devices that are able to connect to their network. So this is the global picture of the SoftFIRE middleware, and the experimenters and the challengers have been using this in order to create their application. I think Simone will provide a little bit more of this information. I think this is the dashboard, and I suppose Simone will provide to you more indication about that. And I would say the software approach to the development of the SoftFIRE middleware was to keep it extensible and customizable. The idea was to describe each resource in a publicly available Tosca definition file, to use the experiment manager to do a little bit of verification about what the resource description looks like, and the sub-manager does the functional validation if the things that are being requested are feasible, and then the experiment manager sends the provide resource message to the sub-manager that will contain the resource to be deployed, and to the sub-manager will execute specific logic based on the kind of specification of that resource. Here you can find some examples of what we have been doing. I will skip a little bit the NFV Manager, all the manager, but the idea here is to provide to you mechanism to use the different functionalities according to your needs. Now we move to a different topic, that is how many different projects we have been supporting. Here you can see we started with a very small number of projects. The important point to note is not how many they are. Just for your knowledge, we have been running more than 30 projects. The first year, it was only a few of those. As you can see, they cover different issues. Typically, the projects were covering security, or they were providing some additional functionalities to the platform, or they were using the platform in order to address a specific application domain. So you can see there are some projects, for instance, modules that are working in order to do intelligent resource allocation for 5G cloud environments, or there are other projects like this one, Aerial Insight, that was using the platform in order to satisfy the needs of their specific application. They were using drones, taking pictures. They produce a lot of content. They were transferring the content on top of the platform, and they were starting to do a little bit of pre-process in order to see if the drones have taken the right pictures, and so they could give a go to the people that are on the field to take the pictures. Yes, you have enough material, you can close the taking of the picture, or you need to do something more because the material you have produced is not good. So you can see very, very different application domains. A lot of experiments were working on video or gaming. So they were putting a lot of pressure on the quantity of information transported. Other people like the CCVP were studying how to efficiently use the platform capabilities, and so they were considering the cost associated to move and the benefits associated to move virtual machines from one platform to the other. So you see very, very different topics. This one is the last open call, the third open call, and you can see there is also Baton that we will discuss later on with specific objects related to bootnets and how to control them. So you have a very large range of different topics and different needs that have been tackled. And another point that we want to make is that we were asking, are you doing this for, let's say, research purposes, scientific excellence, or are you doing this for industrial innovation? Actually, a lot of people were saying we do that for industrial innovation. So that means that a lot of experimenters were doing a lot of work aiming to create products or to consolidate their products into a highly distributed platform. So we think we also supported not just research, but also industrial innovation. I'm near to the closing. So some byproducts we have been creating over the time a rich and complex management infrastructure, because I can assure that dealing with many different projects with many different requirements was quite a job. We also learned by doing, and for instance, we decided at a certain point in time that we needed to have a separation between two environments, one for our own developments and for consolidating the platform, and another one that was a little bit more stable and that was provided to the experimenters. Actually, we were doing two jobs into one. The same team was doing essentially the debugging and was also supporting the services of the platform, and sometimes this has stressed out the people, but I think they did a great job. Another point that was emerging between the first and the second open call was to do a little bit of education, in the sense that people either were not reading the documentation or the documentation was not complete, and so it was not clear to them what to do essentially on the platform. I think we started to do a great job into providing documentation, and I think we also put in place a mentorship and tutorial process by means of which we were able to provide additional information, guidelines, and support to the experimenters. Then what we were doing was, let's say, in Open Call 1 and partially in Open Call 2, we were receiving, some information, some warning that the platform was not properly working by the experimenters. And that was putting us in a situation in which we had to run to fix the things. So we put in place some processes for the monitoring independently from the experimenters. And so we were actually trying to anticipate a little bit the possible troubles and bugs that the platform could show. So during the third open call, I think we did a lot of work for improving the platform, and keep in mind that during the challenge, I think more than 14 teams were using the platform for a reduced period of time, 1.5 months, and they started immediately to fully use the platform because it was a competition. And that has put us under pressure, for sure, because they had very important requests, and we had to be fair to everyone, not give advantage to everyone, and we had to solve all the issues that were coming and to have every team working properly on the platform. And that has been another great experience, I would say, and we learned a lot, and now the platform also during the challenge has been improved and consolidated in order to support future development. So now with the hackathon, with this open day, we believe we have consolidated the platform a lot, and we are are proud of what we have been doing, but we think that there is a lot of value into what we have been doing, and we hope that with this innovation hackathon you will be able to enjoy and to exploit what we have been doing. So that is all for this longer introduction. If you have questions or remarks or curiosity, otherwise I will pass the token to Simone. Okay, Simone, it's up to you. I changed the presenter.
Thanks, Roberto. Let me share the screen. Hi everyone, I'm Simone Pizzimenti from Communication Value Reply, a company that works on security, and I'm involved in a SoftFIRE project in developing the Security Manager, a manager that composes the middleware. During this presentation, I will provide you an overview, a technical review of the middleware, and an introduction to all its components, and also an introduction to the resources that you can request and how you have to request. So after this presentation, you can easily start to play with the platform. To request resources, you have to define and if you are familiar with NFV architecture and terminology, you will not have any problem, because SoftFIRE is based on the ETSI MANO standard. There you can see some useful links. You can see the SoftFIRE website where you can find information about the project, and also there is the SoftFIRE documentation website where you can find all the tutorial in order to define the experiment and other information about the platform. Last is the Slack link that I have previously sent on the chat, and I see that someone has already registered. Now I will show you how to get access to the platform, because before you upload your experiment, you have to enter the platform. As Roberto said, SoftFIRE is an open platform, but not the network. In order to provide a layer of security, we have protected the network with VPN. So during the previous event, during the open call, you have to submit request participation, and after that we evaluate that submission, and we provide you a VPN certificate and credential. For this open day, we have already prepared some certificate and credential that after the presentation we will send to you. SoftFIRE is you can think as a layered architecture, where at the top we have the Experiment Manager dashboard. That is a web page where you can access and upload your experiment and see the status of your experimenter. Under this layer, there is the middleware composed by all the managers and Baton. And at the lower layer, there are the OpenStacks in which the actual resources are deployed. Here, you sorry. Sorry for the issue. I'm back. Here you can see the middleware architecture. There, in the lower part, you can see the OpenStack instances that interact with the Baton, that is the VNF orchestrator, and mediate the creation of the network service and NFV. On top of OpenStack and Baton, we have the experiment manager. You can interact with the experiment manager from the dashboard or from the command line interface. And the experiment manager, we can think as a manager orchestrator that interact with all the SoftFIRE manager. We can see the SDN manager, the monitoring manager, the NFV manager, the security manager, and the physical device manager. All these manager interact with Baton or OpenStack, but the physical device manager is to does interact with Baton because provide access to physical device. But I will talk later about this. There you can see the experiment manager dashboard. You can see on the left pane the reserve resource. By clicking this button, you can upload your experiment, and after that deploy. In the main screen, you can see all the resources that we provide, all the images you can use inside your NFV, all the networks and resource flavor available. Okay, now we talk about the experiment, the actual experiment definition. An experiment is written using the TOSCA language, that is a topology and orchestration specification for cloud application language. The experiment is wrapped inside a CZAR file. It is a zip folder with a precise structure. We can see that inside CZAR we have three main directories. We have the definition directory, where the actual experiment definition reside. We have the TOSCA metadata directory, where we put some metadata information about the experiment. And at last, there is the files directory, where we put some ancillary files that depends on the experiment, on the manager chosen in the experiment. There we can see a full example of a experiment. On the right, we are the metadata that specify, for instance, the name of the experiment and the start and end date. With this data, the experiment manager automatically delete the experiment when expired. More important is the tiosca.meta. The last entry, the entry definition, define the name of the file in where the experiment is defined. In this case, is the experiment.hem. On the left, you can see the experiment.em is structured in the node. Under the node property, you can see the resources requested. Here we can see that we have requested a firewall, an SDN controller, and an iPerf. Associated with these resources, we can see the type that is mapped onto the manager. The firewall, for instance, is a security resource and is handled by the security manager. The SDN Ericsson node is a SDN resource that is managed by the SDN manager, etc. Now we start talking about all the manager, and we show how to define how to request every resources. We start from the most important, let me say, the NFV Manager. The NFV Manager provides NFV resources that represent a network service in the ETSI terminology. This network service is composed by NFV, and each NFV is composed by a virtual deployment unit that is the actual physical resources. The experiment is translated into a network service. This network service is passed to OpenBaton, the orchestrator, and then OpenBaton will contact OpenStack in order to deploy the resources requested. There we can see NFV resource definition. The important part is the resource ID that could be user defined if you want to define a custom resources, or fixed a default ID if you want to use pre-configured NFV resources provided by SoftFIRE. SoftFIRE provide two pre-configured NFV resources. Provide provide an iPerf resources and an OpenEMS resource. But you can find all this information on the docs website. After that, we can see that there is a testbed property. Inside this property, you can specify the actual OpenStack you want to use to deploy, to physically deploy the resource. That is the virtual deployment unit. After that, you can see the SSH pub key property, in which you define your SSH public key in order to get access to the resource that you instantiate. The last property is the file name property that is optional and is used only if you want to define your custom NFV resource. There you define a path of a file that is placed inside the files directory in the Caesar archive, and inside this file you declare a custom network service using the OpenBaton specification, and you can go on the OpenBaton documentation to see how to write a custom resource. After that, after the NFV Manager, we have the Physical Resource Manager that, in this case, that provide access to physical resource. In this case, you have to go to Focus or SARE to have access to this phone. Declaring the experiment has no effect. You only request to have access to this resource, and then you have to go to Focus or SARE to use the phone that is attached to a 5G cell. For the OpenDay, we don't provide access to physical resource because we have to prepare this device, and we unfortunately don't have too much time during the OpenDay. Now we have the SDN Manager that provide access to the SDN controller that permit to interact with the virtual switch and to control the traffic inside the SoftFIRE network, inside your experiment network. You can mirror, divert, or drop the traffic. Inside SoftFIRE, we decided to use two implementations of SDN controller. We have OpenDaylight inside Ericsson testbed, and we have openSDNcore inside the Focus testbed. To request this kind of resource, you have to declare SDN node that have the SDN resource type, and inside the ID you have to specify what controller you want to use. Because in each test that we have only one instance of the SDN controller, we had to expose to make available to the experimenter let me say a wrapper in order to isolate the traffic of the single experimenter. This wrapper is called the SDN proxy. In this slide, we show the OpenDaylight proxy. That is a wrapper of the OpenDaylight OpenFlow API. You perform an API request, and you can instruct the controller to execute some commands. I decided to show you only an example of the ODL proxy because after my presentation, the SoftFIRE experimenter will show you, will demonstrate a live tutorial that the ODL proxy. There you can see the Experiment Manager dashboard. You can see that I have requested a SDN resource, and you can see in the figure the output that show you some information related to the SDN resource, and now we will use this information to send command to the controller. There you can see the URI address that you have to use to use the API, and the experiment token that is necessary to perform the API call. There you can see API call performed by a curl command. You can see that we put the URI provided by the Experiment Manager dashboard, and there we want to send a command. We have to insert in the query the token provided by Experiment Manager, and also the OpenFlow device that also is provided inside the Experiment Manager dashboard. There you can see the JSON body of the command we want to send to the SDN controller. You can see that is divided in two parts. The first is a match rule, and the second is an extraction rule. The first, the match rule is needed in order to match a traffic flow. In this case, we want to match all the traffic that is that has destination precise IP address, IPv4 address. After we match a traffic flow, we apply an extraction rule. In this case, is a drop action. That is, we drop all the traffic that match the rule. On the SoftFIRE documentation, you can find the full tutorial of this example. Okay, now we have the security resources provided by the security manager. Security resources are resource that NFV resource that run security agent already pre-configured. The security manager automate the deployment of this resource and handle all the life cycle. The security resources that we provide are free, are a firewall based on UFV, that is a wrapper of PP table. We provide the EDS Suricata, and we provide the pfSense open source firewall router. Also, you can decide to install this agent inside another NFV resource, because your experiment is complex. So you can ask the security manager only to provide you the scripts to install this agent inside another NFV resource. There you can see the security resource definition. Starting from the left, we see the Suricata resource. All the resources share some common property, but each resource has their specific property. In fact, Suricata has the rules property, inside which you can specify some default rule that will apply as soon the resource is deployed. Instead, inside the firewall resource, there are you can specify some default firewall rule, or specify some a blacklist of IP. For each, for both Suricata and firewall, we provide also a login functionality. We provide a shared instance of a Kibana server that collect all the Suricata and firewall resources log, and we provide you a isolated dashboard which you can use to see these logs. The want-to-agent property used to download the agent without deploying the resource. As I said before, in order to install the agent inside another NFV. And in the end, you can see the testbed destination of the resource and the name of the network in which you want to attach the resource. pfSense resource is a little different. They have only the ID and the network in which you attach pfSense, but it doesn't have the SSH key property because to access the pfSense we provide the default credential that you can see on the experiment manager dashboard as soon the pfSense is deployed. Here you can see some other functionality we offer for the security resource. Specifically for the firewall resource, we provide an API in order to manipulate the firewall rule. In the top figure, you can see the experiment manager output that show the resource information, the status, the IP, the Kibana dashboard log link, and the API URL. Using this URL, you can perform some API request like get the status of the firewall. You can see on the right an output of this command. You can see the rule running on the firewall, or you can submit an API call in order to push some rules on the firewall without logging via SSH on the actual resource. In the end, you can see the Kibana login dashboard is a pre-configured dashboard that collect, in this case, all the firewall logs, and is also available for Suricata. In this slide, you can see instead you can see the pfSense web dashboard. If you are familiar with pfSense, you will know that provide a dashboard in order to configure and see the status of the resources attached to the network controlled by pfSense. The last resource is the monitoring resource. We can think as a twin of the security manager. In fact, also the monitoring manager provide a NFV resource configured with a specific product. In this case, a Zabbix server. A Zabbix server is a server that permits to monitor the status of the resources that you want to monitor. You to request a monitoring resource, you have to declare a monitoring node that the type of a monitoring resource. You have to choose in which testbed you want to deploy, and you have also to choose the network that the monitoring resource will use. After that, you have a Zabbix server, and then if you want to monitor, for instance, a virtual machine, you have to install inside this virtual machine a Zabbix agent that will communicate with this Zabbix server. There you can see the Zabbix dashboard that provide you some information. Thank you. My presentation is ended. If you want to ask some question, I can reply you, or also other SoftFIRE people can reply you.
Vibra.
Okay. So now we with a live demo that will show the Baton Fire experiment. That and we have Gregorio Martin Perez and Manuel Gil Perez from Universidad de Murcia that will present this live demo.
Okay, thank you, Simone. I'm going to share my screen. So pass me the token, please.
Yep, just a second.
Yeah. Okay, perfect. I suppose that you can see my screen right now. Okay. Hi all. So I'm Manuel Gil Perez from the University of Murcia. So I'm on behalf of the cybersecurity group that we are here at the University of Murcia and led by Gregorio Martinez Perez. So I'm going to present, first, I'm going to present how we have deployed all the different network services in the SoftFIRE platform. After that, to show a live demo in order to see exactly how we deploy the things and the different capabilities that we try to provide to the SoftFIRE platform. In this case, our intention with this experiment was to include cybersecurity capabilities to the SoftFIRE platform in order to protect the users that are using the network, but not only that, but also the SoftFIRE components that they have there implemented, the infrastructure itself, in order to be protected against different kind of cyber threats. For example, in our case, security threats related to botnets. So in this case, as commented, the detection and mitigation of cyber threats by using the combination of both technologies, the NFV and SDN technologies, that we can use by using the SoftFIRE network. So in this kind, as you can see there in the picture, so we have deployed different NFVs, we have deployed an SDN app in order to control the different traffic from the different bots that are belonging to the botnet, and the CNC server, that is the command and control server, in which an attacker is going to manage all the different network in order to try, or in the future, to order to the different bots a kind of an attack. For example, a classical one is the HTTP float attack, in order to disroute some kind of victim, for example, a machine there in the SoftFIRE network, some kind of things that we can to the root. So in this case, so we deployed two different BNF, so a Snort and a Honeynet. The Snort for the detection capabilities in order to know exactly if the different users, the devices of the users that we have in the network, they are really a bot that time to time is requesting an action for the CNC server in order to know if they have to execute something or not. So this process is a classical philosophy of a botnet, in which the bots are requesting time to time, are requesting action to the CNC server. So when the real attacker at the end decide to execute something, so by using the CNC server, she can include a new attack order in order to be deployed to the different bots that in a collaborative way are going to execute the attack against a given victim. So for that, the Snort is deployed, this is a BNF deployed with IDS function in order to inspect traffic, in order to know if the different devices in our network, they are really a bot or not. So in case that we we detect that a new bot are there in our network, so our intention is to deploy a Honeynet that is a mechanism in order to emulate the behavior of the real bots, so against the CNC server. So in this case, the Honeynet is solely to mitigate, in this case, not to another reaction. So not to avoid, we are going to avoid the problem, but not to remove the real problematic that we have with the bot, but just to to try to mitigate the problem in order to, in a case in a future, the CNC decide to execute something, the bots are not going to receive anything, but the honeypots are going to be as a proxy in order to avoid a future attack. So this is our two different BNF for the detection and mitigation purposes. And after that, we have also an SDN app in order to configure, in this case, the SDN controller in order to provide two different features. In this case, the mirroring to send copy of the different packages between bots and the CNC server directly to Snort in order to be analyzed. And after that, another kind of rule, the diversion rule, in order to redirect the traffic between bots and CNC, we are going to redirect to the honeynet in order to avoid that the bots are going to receive the actions and execute something. So in this case, at the end, in the honeynet, we are going to isolate the problem there, and the bots are not going to know exactly if they need to execute something or not. This is our different BNF and the SDN app that we have in our network. So as you can see in the picture, so the different BNF are deployed there in the SoftFIRE network, but the management layer app that we deploy in order to reconfigure all the different BNF and then reconfigure the platform, not little, but our resources. So we implemented a management layer app by including also the flow-UT to remotely configure the SDN controller and to provide that kind of feature, the mirroring and diversion rules. In this case, only to know that part, so on top of the picture, you can see that we deployed two different bots, simulating that both at the same device that are used by the same user. So in order to simulate that the user is moving from one part of the network to another, and the bot that is installed there in his device, so it's going to be moved to another part. In this case, if we are expecting the bot or mitigating its behavior, we have to reconfigure the different BNF in order to continue providing the mitigation or detection capabilities. So this is the different steps that after that I'm going to present in the live demo. So initially, we have a botnet channel in which the bots are requesting some kind of action to the command and control server. And after that, the different step 2 and 3. So to show how the detection process, we have to reconfigure Snort to include a new detection rule to Snort in order to see if the traffic shared between bots and CNC server are really part of the botnet or not. And for that, also, we need to reconfigure the flow table of the Open Virtual Switch in order to apply, in this case, the mirroring capability in order to receive Snort the different traffic share between the bots and the command and control server. So at the end of this process, the beginning, the detection, Snort is going to receive the different package exchange between the botnet, and if in case Snort detects something, so it's going to generate alerts alerting about that we have a problem, we have there a botnet that we have to mitigate. So regarding the mitigation process, when the bot is detected as a botnet, so we are going to reconfigure the honeynet in order to launch a new fake bot. Is really fake, so emulating the behavior of the real bot. So in this case, we are going to isolate the behavior of the real bot. The real bot is not going to receive action for the CNC server, but the action will be received by the honeynet. In this case, if from the honeynet perspective, if we receive an action, we are not going to execute anything, of course. So for that, at the end, in order to enable the honeynet capability, we have to reconfigure also the Open Virtual Switch, the flow tables, in order to apply the diversion rule. In order to, when the honeynet send a new request to the CNC server. We are going to change the IP address of the honeynet for the bot that we are emulating, and the CNC server are going to see a request so that thinks that is a real bot, when in reality is the honeynet. So at the contrary, in the response, the CNC server response will be received through the Open Virtual Switch, and we are going to change the IP address of the destination, that is the real bot, for the new one, that is the honeynet. So in this case, the real bot is not going to receive anything, and the honeynet will receive the response from the CNC server. This is our idea of our experiment in order to provide security to the SoftFIRE network, not only the user, but also the different components that we have there deployed. So I'm going to pass to show you what we deployed there. This is the SoftFIRE middleware that has been presented by Simone. So in this case, it's I'm connected there with the different, we can see here different resources right now available. For example, the perf presented by him, so not only that, but Suricata, for example, the SDN controller deployed there in Horizon in order with the OpenDaylight, another on focus on by using the openSDNcore. We have all the different resources already deployed, but also we can deploy custom resources in order to provide our functionalities. In this case, we have already deployed the experiment that we can see here. We divided the experiment in 3 parts: the CNC, the SDN part, the real bots, and also the virtual security function, that is the honeynet and Snort. So, for example, regarding the CNC server that we have here, this is all the information regarding that kind of BNF. So for that, we can see right now that it's active with the different private floating IPs that we can use there in order to connect remotely to the VM. This is an example. And also here we have deployed our SDN controller in order to have access to the flow tables there in the Open Virtual Switch on Ericsson. So we have here all the information regarding the URI, the token in order to add or to remove some kind of flow there, and the different tables that had been presented before. So that we have a lot of different information there, the tutorials, documents, and so on in the SoftFIRE website. We can to check all the things. So a lot of different experiments perfectly define how to use and to deploy the different NFV, SDN resources here in the experiment. So this is regarding the CNC SDN. The real box, for example, we have here deploy different resources. So we have in total 6, but are going to only to present 3 of them. So with all the different information as before, the private floating APs and so on. This is the information regarding the real bot deploy. And after that, also regarding the Snort and the honeynet, so it's the same than before. So with they are active right now in order to be used with all the different network services here defined. So it's perfect right now. So in order to deploy this kind of experiments, in order to another example as Simone has presented before. So we deploy for that. We use this kind of information. So sorry. This is the different CSAR files that we use in order to deploy the 3 kind of the same experiment in 3 parts here in the SoftFIRE middleware. So for example, regarding the CNC and SDN that I have been presented before. So the TOSC data folder is the same presented by Simone. In this case, only, okay, with the information, with the version, who is the company that created this kind of CSAR file, and so on. So the metadata presented by Simone, so only the name of the experiment and the dates in order to be used to deploy there in the middleware. So I'm going to show you the definition part. This is the definition for the, at the beginning for the CNC server. This is a NFV resource in which we have the definition of the network service descriptor in order to define, okay, the testbed in which we are going to deploy this kind of component is on Ericsson, the public key that in order to have access later via SSH, we have here the public key, and also when we have the file defining this kind of network service. So in file CSAR, we have here the same kind of structure than before. In the definition part, we have the complete definition about the CNC server. So in this case, the CNC server, that is this last part, we define the different things, the interfaces, some kind of script that we are going to execute after deploying the component, and also the property that we have, which is the flavor, for example, that we need in order to deploy the VM. So which is the type, in this case, of the network service descriptor. So who is the person, blah, blah, and the requirements about which is the virtual deployment unit in which will be deployed this kind of VNF. In this case, that is defined here. So we are going to use this kind of VM is with this name, and this is a VM and with different properties in order to be deployed here on Ericsson. So with some kind of requirements that here, that is the logical connection point entity that is defined as so that we have here where is going to be deployed and which is the different requirements. For example, we are going to, in our virtual link, is going to be deploying this kind of virtual deployment unit and so on. This is, all of this is defined in Tosca. So in which they are in the SoftFIRE website, we have different tutorials, documentation in order to check it. So before deploying this, because if we are accustomed to try to define our experiment with Tosca, there is no problem, but also we have the help from the mentor, in this case by using the Slack or directly via mail with the mentors. So they have provided a lot of help in order to define properly this kind of file, okay? So it's regarding the Tosca definition in CSAR. So for the rest is the same. So for the real bots and the honeynet snort is the same philosophy that I have just presented. So I'm going to pass to directly execute the live demo in order to show the functionality of our experiment. So here we defined the management layer application that is on top of the network on top of Baton in this case, in order to reconfigure the VNF that we have deployed and also to provide the different functionalities and in some sense a workflow and a storyline of the thing that we are going to check. For that we have here the snort is in this part, so the honeynet also already defined with the different floating private IPs by the SoftFIRE middleware. So the bots that we have here, the bot 1 in this case separated, but the bot 2 and bot 3 is to simulate the movement of the bots in order to show reconfiguration capabilities. And also we have here the CNC server that we deploy, we implemented, and the CNC controller, that is the URI and the token that I presented at the beginning here, that is directly copy and paste there in our application, not the same. So we have also here all the most important part in order to show our experiment. So this is bot 1, This is the CNC server, this is defined there, the snort, and the honeynet, okay, in order to show how is working our experiment. So at the beginning, we are going to which is the real functionality of the CNC server, how a bot is recruited there in the CNC server. The CNC server is this. I'm going to enter. Give me a second. Now, this is the CNC server is used by the real attacker at the end, in which we are going to show here all the different bots that are recruited here in the CNC server in the botnet. Okay. So for that, this is the CNC server. I'm going to show the logging that what is happening here. Sorry. In order to check only the HTTP requests from the bot in order to show what is happening really. So regarding the bots, this is the application that we implemented, is the bot. So this is the IP address of the command and control server, that is this. And after that, the frequency in which, in seconds, the frequency requesting different actions to the command and control every 10 seconds. And also a verbose option in order to show here what is doing the bot. And execute this. And in this case, we can see directly when we receive here that a new bot had been added here in the CNC server. We are going to check it directly in the dashboard of the attacker. So we have here a new bot, bot1, with this IP address, and right now is connected in order to execute something. So for that, we are going to execute an initial short attack in order to show the functionality of a botnet. So for that, we are going to use this bot. We are going to execute a HTTP flow attack. Here we will put is this, the IP address of the victim and the time executing the attack. In this case, every during 20 seconds, we are going to execute the HTTP attack. So we send that we see here in the consoles. So we receive the attack, and now the attack is starting. So it's only by using only one short bot. So the attack is not problematic right now, but imagine, for example, the real botnets with Configure, for example, is the biggest one 2 years ago with 9 million of different bots recruited within Configure. So if we use 9 million of recruited or compromised devices in order to execute an attack, for sure that the victim is going to be crashed. So the attack is finished. It's only to show you. So it is the functionality of a botnet. Okay, so initially here snort is not receiving anything. So because it's not configured right now in order to detect anything. The second one. So here we see that the bot continuously every 10 seconds, that is the frequency of the bot, is requesting something, but the snort is not configured for that, and the snort is not receiving anything. So for that, we pass again to the dashboard of the management layer app. So in order to define a new rule, a detection rule there in snort, in order to expect that if we have a real botnet or not. For that, we are going to send the detection rule to the snort BNF. So, and also we have to reconfigure, in this case, the SDN, through the SDN controller, we are going to reconfigure the flow tables of the Open Virtual Switch in order to mirror the traffic to snort. So, perfectly configured. With this detection rule that we have here, this is the source, which is the destination, and a kind of detection rule in order to detect a kind of botnet like this that we deployed. Here, if we pass to see this kind, then Snort is now receiving the different traffic that is changed between the bot and the command and control. We see here all the different traffic sent between them. So with this, Snort is detecting something. So this is the alerts produced by Snort that is defining IDMF format, that is a standard format to provide a new alert when it's detected. So in this case, we are going to see one of them. So this is the IDMF format in which we have the different information about the time created the alert, which is the source that is this, that is the bot. This is the target, that is the command and control, the type of botnet that we are using that is based on Zeus. So this is the alert provided by Snort. Okay. So in order to see the functionality of our Float SDN app, in order to add a new rule, in this case for Snort is the mirroring rule. So we are going to check directly through Postman. We are going to receive the information from there, from the SDN controller. We are going to receive information that belongs to our experiment, that we have assigned this kind of table is table 2, and we can see in the SoftFIRE middleware, the table 2, that is the first one. So we are going to check all the different information that we can to include there in the SDN controller, through the SDN controller. This is the output, the JSON, and our new rule that is called something mirror something. This is the rule that we have deployed there in the OBS suite through the SDN controller by using our Float SDN app. So by using which is the source, which is the destination, this is the source that is the bot, destination that is the CNC server. So, and we are going to say that this kind of traffic is going to continue through the next table, that is the 70th, that is the one for the output of the Open Virtual Suite defined there in SoftFIRE. So, but also we are going to send a copy to a VM that is connected directly to this OBS port. That is the 75, that is defined. We have to retrieve that kind of information from the SDN controller. So we can see that in this case that is not connected to this kind of port. Okay. We're back again here. So in this case, the next step. So we are going to include also the bot 2. We are going to execute it. Okay. We are going to execute it remotely by using this kind of frequency. This is the UUID defined for the bot. So, and now Snort is going, Snort is not configured right now for detecting this. We are only going to execute it. So from the CN server perspective, so sorry. So in this case, the CNC server, we can see that we have a new botnet already recruited. So that is the bot 3. In this case, the name is changed, but it's the same. So it is kind of this kind of bot that right now is not expected by the Snort. We are going to include a new detection rule in Snort, as we have done before, in the same way. Now it's configured. The new mirroring rule has been included in the Open Virtual Suite flow tables. And we can see here that there is a new source that is this, that bot 2. So both of them, bot 1 and bot 2, are going to be expected and are detected at as real bots that we have by using a botnet. So it's the same as before, but now, for example, in order to simulate that the bot is moving from one part to another, we are going to move a bot 2 to another bot with the IP address from here, from this IP address to this, and we need to reconfigure the snort in order to date the current detection rule for the same one, but using a new IP address. For that, we have to remotely, to reconfigure the snort in order to provide that functionality, and also the mirroring part will have to be updated. So in this case, we simulate this by clicking on here. So we move from here to here. And now in the next time, we are going to reconfigure here the detection rule. Right now, we can see that the IP address is changed. And now from the last alert that we detected here by using this kind of bot with the 18. So now the next one should be appear as the new IP address that is 20. So have that we reconfigure snort properly in order to continuously analyzing the bot, even the bot is moving from one part to another of the network. In this case, we see from the CSC perspective, if we refresh the dashboard, we can see that now we are in another. So we have a new IP address, but from the perspective of the real attacker, so there is the same bot than before, but now with a new kind of with a new IP address, no more. It's a movement part. Okay, so we detected that the bots are detected by snort, and now we are going to execute the mitigation phase that by using the honeynet. We are going first to emulate the behavior of the bot 1. In this case, we are going to send the configuration to the honeynet, and we are going also to include a new network flow diversion rule there into the Open Virtual Switch through the SDN controller that we have assigned there in Ericsson. In this case, the new process is properly configured. We can see here, we remove also the detection rule from snort because it's not necessary right now because it's detected. And now the bot is being emulated by our honeynet BNF. That means that right now, as we can see here, the real bot is not sending or receiving any kind of request to the CNC server. All this information is done directly by the honeynet. So in this case, if we send, as before, if we send an attack that is bot 1 is this, we send the same attack than before. Okay, we can see here that the CNC server that is the victim of the attack, really, so it's not going to receive the real attack because the attack is received by the honeynet, but the honeynet is not going to execute the attack. So we are not receiving anything because the real bot is not receiving the action. Okay, continue. This case, we also include, for example, another bot that is right now under inspection but is not being mitigated by the honeynet. We are going to include a non of emulation process. In this case, for the bot 2 or 3, so it's the same kind of bot. So we execute the same steps than before. Now, snort is empty of configuration because no bots is being analyzed by snort, and all snort that we have here, 2 different bots, are being emulated by using the honeynet, the behavior that they have against our network, against the CNC server. Right now, if we check again the CNC server. We refresh the page. From the attacker perspective, we see that two both continue being collected. So they are here right now, but they are not going to receive a real action in order to execute that real action. If we, as before, if we simulate a movement from one part of the network to another, changing the IP address, so as before we did with the snort, so we are going to reconfigure the Honeynet BNF, and also we have to update the diversion configuration that we have deployed right now. So we have to update everything there to continue provide the mitigation purposes. So from here, this is the new IP address is this, is the 18 that we can see here is the, no, this is configured for the, this is the UUID that we have for this kind of bot. The bot is being emulated, continually emulating by our solution, by our Honeynet BNF. And from the perspective for the CNC, everything continue again than before. So there is not a change there in our network. So, but at least we are protected against real attacks that the botnet can be executed externally. So this is all the experiment that we implemented there in the SoftFIRE middleware. So that is all. I don't know if you have, you know, I pass directly the token to Simone in order to continue the event.
Okay, I'll be speaking. At this point, if anybody has some question, we are open to answer you directly now here in GoToMeeting. So I'll give you all the opportunity to make some question about all the introduction by Roberto, Simone, and Gregorio, Emmanuel, and up to the external team make some question. In the meantime, about the schedule, we will open the platform at 3 p.m. It says time +2. That means the Italian time at 2 o'clock, at 3 o'clock, sorry, 3 o'clock Italian time. And will be open until 6 o'clock p.m. Italian time for today. Tomorrow we will open at 10 o'clock in the morning Italian time until 6 o'clock Italian time tomorrow afternoon. Any question?
Yeah, do we have the login information to get into the platform? Well, for the VPN and everything, do we?
Sorry, can you repeat the question?
Yeah, we'll have to connect to the VPN, right?
Okay, yeah. Simone will provide you the certificate and the password after this call, okay, and support you with the other partners on Slack to solve any issue that can be you face in the connection phase. Okay. So after the end of the meeting, Simone will contact you personally, the team leader, and I mean properly. Stefano Sartorelli for Adscom, Eric Fernandez for Vodafone, and Mohamed Zizan Asgar for the university. And these 3 persons will receive the certificate, the passwords, and all the instruction to make the connection. If you are not the leader, the proper leader that have requested authentication, please contact me and Simone to change the reference of the team. So in this moment, this free person will receive the certificate and the password. I don't see in this chat Stefano Sartorelli from Adscom. Daniele Carmignani, you will be today. Okay, no problem, Daniele. So I think we can send you the certificate and the password instead of Stefano Sartorelli, as Stefano have included you in the team, so no problem. So Eric Fernandez, Mohamed, and Daniele will receive properly the certificate and the password for your team, okay?
Yep, perfect.
Okay. All of you have joined the Slack channel?
Yep.
Okay, perfect. All of you have access granted, so you can chat, ask question on the general channel.
Okay, just
I
posted a hi.
see in this moment Eric have completed the access. I suppose Daniel have have the access. I suggest also to Mohamed and the university team to join the channel as soon as possible. Okay, I see you also on Slack. Perfect. Okay, just a clarification. You will receive a zip file, the free person data list with the certificate,
plus credential.
with the credential, and the final password will be sent on Slack channel to your user. So to Eric, Ashgar, and Daniele on Slack. Okay. If there is no more question for now, we can close the chat on GoToMeeting and move directly on Slack to all the conversation about the Open Day. Okay, I would like to. Yeah, about this recording. Probably I need some time to complete the, I can say, production of the file on my PC. It will take about half an hour, and I contact you as Vodafone as soon as possible when the video will be available. It will take some time to produce the final video because we are recording directly on GoToMeeting. Sorry. Okay. You're welcome. And we can share the slide if you need, maybe as a content on Slack. On the general Slack, we can put the slide used by Simone that also includes the one used by Università de Muscia for their presentation by Manuel and Gregorio.
Fabio, you should have also mine if they need it.
Yeah, okay. I can also add that. Okay, no problem. Absolutely. I can put them, both of them on Slack, so you can take a look on them. Okay. Thank you everybody for coming here in this tutorial of SoftFIRE. And we will see you again soon on Slack, on the SoftFIRE platform, and enjoy your time in those 2 days. Okay. Thank you, everybody. Bye-bye.
Bye.
Bye.
Bye. Thank you.
Guys. Bye.